So instead of having a .py, I'm actually going to be changing this to a Jupyter notebook. So IPyNB. Apparently I had to click open up with the notebook editor. So there we go. Let's go ahead and actually go ahead and select our kernel. You can go ahead and choose the latest version of Python. So when it comes to actually installing the libraries, you want to first of all import the necessary modules. Okay, import the modules. So the first one we're actually going to need is NumPy. So import NumPy as NP. Now NP is a common alias for NumPy, and we need to import Pandas as PD, and then we need to import Matplotlib. And essentially we want to go to the pyplot thing, and then PLT is going to be the alias. We also want to import Seaborn as SNS. And now comes the actual machine learning. So first of all, we need to do from scikit-learn dot model selection import the train test split. And as you see here, this is a function, but for actually making the linear regression, we're going to have to import from scikit-learn dot linear underscore model import linear regression. And yeah, make sure the linear regression is both capitalized. If you don't have these libraries, you will need to actually install all of these. So using pip install, and then let's say NumPy or whatever libraries you have. So I'm actually going to show you how to install these. So pip install NumPy. Okay, so let's take two. I forgot to update my pip. So, okay, pip install NumPy. And as you see, the requirement is already satisfied for me. But if you don't have this already, then you may see something else. Like you may see some bars or meters like this that show how far in the installation process you go. Similarly, you'll want to do it for Pandas, Matplotlib. So Matplotlib is going to be this one, and then Seaborn, pip install. And then we're going to have pip install. Instead of scikit-learn, it's going to be scikit-learn. Let's go ahead and actually start. So let's actually go ahead and read our dataset. So the dataset that I'm going to be using is the car underscore price underscore dataset. And I'm going to link the dataset to there as well. And then what we're also going to want to do is read the CSV. So store this somewhere, obviously. So we have the data frame equals pd dot read underscore CSV. There's also a ton of formats, like there's read CSV, Excel, Feather, HTML, even Pickle, which is useful for importing existing ML models as well. So then inside the brackets, we want to put car price, and then underscore dataset. And we also got to make sure that we include the CSV file. And now to check if it's working, we want to go ahead and print the data frame. So there we go. Okay, so as you see here, this signifies a new line here. As you see, there's 1, 2, 3, 4, 5, 6, 10 columns. So notice here that these numbers here that don't correspond to like a column refers to the index number. And now the index number will not matter in this case. But what does matter is going to be the fields that we are going to be performing the linear regression on. So that is basically going to be it for reading the data. So let's actually go ahead and do sns.pairplots. We can only have like one parameter here. We can have data equals the new data frame that we just read. So df. Now it will take some time, but when it comes, you will see a kind of 2D matrix of graphs. Okay, so here we go. This is technically going to be the pair plot. So as you see, there are going to be, okay, so as you see, we have the year, engine size, mileage, doors, owner count, and then we have price. So that is essentially going to be, that's for the columns here. We have the owner count, then doors, mileage, engine size, year, and that as well. Now, right now, this data doesn't look clean, and we want to see if we can make this data more obvious. So we have to go ahead and clean up our data. So right now, you can see that this immediately looks bad, I'm going to say, but we're going to make it look better. So here's what we're going to do first. So we're going to have df equals, so we're going to have our data frame, and then we have df dot. Now there are two methods what we want. We want to first clear the duplicates, so drop duplicates After looking through these graphs, you can immediately tell that the year and price is going to be pretty accurate. Similarly, the engine size and price, and then mileage and price. But for this case, we're going to go with the year and the price. Our first parameter, essentially, we have our subset. So subset is equivalent to year, and if we want this in place, we can essentially keep it to be true. And then we can do sns.pairplot df again. Okay, I think I got something wrong. So, okay, I got a fix. So I had to make sure I ran the previous query where to find this thing. After we drop the duplicates, we should have a much more accurate model. But what we could also do is drop the NA, which is useful for datasets that have empty values as well. Let me run the other cells. And then we're also going to be running this pair plot. We're going to pay attention to the year and price graph here. And yeah, you can essentially see that this is very clean. There are no duplicates. For example, if you put a vertical line, you'll see that no 2 points fall within the same vertical line. So we're good here. Let's go ahead now and actually start training the model. We're going to first of all choose the columns that we're going to choose. So we have our X data, and we're going to have it capital X, because scikit-learn loves to use capital X, and also X could refer to a bigger piece of data. X refers to a matrix here. So our X data will be our data frame with our column, let's say year, and our Y data will be our data frame, and then let's say we have price. And then we also want to make sure that we shape this as well. So X underscore data equals NumPy dot array. So we're going to do np.array, and then let's say our previous X data, and then we also want to reshape this thing. So -1, 1. And then similarly, we can also do this for the Y data. So np array, Y data, and then reshape -1, 1. Now -1 is essentially an inference, and since we only have like 2 values, this is why -1, 1 works. Let's go ahead and print our data. Hold up, I think I messed up the casing. There we go. So notice here that our output has been truncated. So yeah, here we go. We have this one refers to the prices, and then these are basically the years. There we go. We have a NumPy array, and it should be a 2-dimensional array, which is ideal for this purpose here. So yeah, that's going to be it for actually preparing the data. We can go ahead and make some variables. We're going to make 4 to be exact. We're going to make xtrain, xtest, and then ytrain, and then ytest. And that'll be equivalent to our train test split. And then our arrays are going to be whatever we did earlier. So our x data, y data. So our x data. And then we also have y data. And then we are also going to have 2 parameters as well. We can have first our test size. So our test size is going to be a float between 0 and 1. Now 0 means that there's going to be no test data, while 1 means that all the data is the test data. So typically 0.3 or 0.25 is the suggested split here, but we're going to go with 0.3 here, meaning that 70% of the data will be used for training. So yeah, that's going to be it for the training and testing. So we can go ahead and actually plot the train data. We can use Matplotlib for this. So plt.scatter, and then here we have this thing here. I forgot to say this, but okay, we have plt.scatter, and then what we want to do is say x be equivalent to xtrain, and then y is equivalent to ytrain, and then we can also scatter xtest and ytest. Let's go ahead and do something like this. As you see here, we have some of our data is going for training, and some of our data is going in testing. If this data was sorted, then you can pretty much have this much data for the training, and then this will be the testing. Also, before we progress further, I'm going to make sure that we get the titles here. So, preparing our data, training the model. And yeah, now we can move on to the actual linear regression. So, first we're going to make an instance of a linear regression. We're going to call it lin_reg, and then we're going to set it to a linear regression object that we imported from scikit-learn. And now what we want to do is basically fit the training data. This is why we have training and testing data. So visually, the training data will be fitting all of this data essentially. So yeah, we want to do len_reg.fit, and then what we want to do is set our x to be xtrain. So our xtrain is going to be here, and our y is going to be y_train. So yeah, that's it for actually fitting the model. Now, what if we want to actually plot the linear regression somewhere? Now, what we want to do first is y prediction will be equivalent to, let's say here we have, let's say here, len_reg dot predict, and then we have this thing here. So, okay, essentially this line I meant to say. So instead of y prediction, it'll be x test this time, because the prediction is going to be the result here. Like this line here represents the prediction results, like what the price should be at a particular year, or at least close to it. So after we have this prediction, what we want to do now is basically add it to, let's say, the line. So first of all, what we want to do is add the scatter plot yet again. Don't worry, I'll make this more comprehensive towards the end of this video. I'll make some major tweaks here. We have our training data, our testing data, and finally we want to go ahead and plot our line. Now, if we want to plot a line, then we have to do plt.plot, and then we are going to have, is what we want to do is we have our y_prediction. Okay, my bad, I forgot to say we have the x test and then the y prediction. My bad. Okay, so this should be good, though I will actually change the color of this. So I will add a third parameter called color, and then that'll be equivalent to, let's say here we have red. And there we go, we have our regression model here. Now, let's test our accuracy here. So we're going to have a new title, so we're going to say, okay, how accurate? So we're going to do a linear regression on both the training and testing data. Now, it is guaranteed that the actual line is going to be 100% accurate, so we're not going to consider this one. So first of all, what we want to print, we're going to print linear regression accuracies, and then what we want to do is print a new line. So we're going to have training first, and then we're going to have testing. And don't worry, I'm modifying the last two lines. So we're going to have a comma, and then we are going to say our xtrain inside one of our parameters here. So we're going to do len_reg.score. And then we also need ytrain. And then we also want to substitute the train for test for both x and y in the testing area. So yeah, after we're done training the model, it should be good here. So our training model is going to be 0.4721, or at least that much, and then our testing is going to be 0.49137. But yeah, that's going to be it for actually making a model. We know what it feels like to make our very first model. This is probably one of the simplest machine learning models you're ever going to create. But yeah, anyway, that will wrap up this video here. So if you guys enjoyed, make sure you leave a like, subscribe, turn on post notifications for more videos like this, and of course, see you guys in another video. Peace out.